Welcome. Today we're going to be talking about the first SAC for the 2021 Mathematical Methods Unit 3. This task is broken up into two parts. We have part 1, which we are calling Jasmine's Flower Dome, and part 2, which we are calling Hui's Hot Horticulture. I'm going to be discussing with each part just the front cover items, things that you need to be aware of, and then giving you a context for each part. So let's start with part 1, Jasmine's Flower Dome. So on the front cover, you're going to see that you have 120 minutes to complete the task. There's roughly around 20 questions that you'll need to answer. You need to make sure that you are giving answers to 2 decimal places unless stated otherwise. So unless it states exact values, your answer should be in 2 decimal places. CAS and scientific calculators will be permitted, as will a bound reference will be permitted for this task as well. So the context of this task reads like so. As a budding horticulturalist, Jasmine purchased 100 hectares of prime agricultural land in northern New South Wales. The land that she buys is relatively flat, with the Moobi River flowing through the property. An initial survey of the land is presented in the diagram below, with the far southwest corner given the coordinates 0, 0. So if I bring up the graph of this land, what we're saying here is that this corner, 0, 0, is what we are terming the far southwest corner of the property. And the property is bounded by these parameters, or these lines. Okay? So this line could be written as x equals 100, and this line could be written as y equals 100. You need to make sure that you're aware of that. Now the Moobi River is represented by this curve. Okay? You'll be given the curve in the task. Okay, and it flows straight through the property. All right? Okay. Your considerations with this you need to know where north, east, south and west are. You won't have to, let's say, you won't have to say, this direction north, this direction south, this direction east, or you won't have to say northeast, southeast, stuff like that. But you do need to orientate yourself with the north being shown here. The green shading, other thing that you need to consider is this. The green shading represents the property with the boundaries set along the x-axis, y-axis, y equals 1,000 and x equals 1,000 metre lines. Okay, so I probably need to correct these equations. They're not 100. They're 1,000 metres. Okay, so you need to be aware of that. Now, obviously, what you're going to get asked here is you're going to be asked to find, a location where Jasmine's going to build her flower dome. So she might build it there, for example. And you're going to be asked certain parameters or certain questions around that location, and its orientation to the river, its orientation within the property, and distances involved. Okay, so Jasmine wants to construct a flower dome on the property, but is also aware that the local planning laws require her to construct such a building at least 100 metres from the river due to flood risk. Now that's common sense. We don't want to be building very close to the river, because when it does flood, obviously our flower dome is going to get inundated, so we want to be set back from the river an ample amount of distance. Okay, so the local planning laws are suggesting that we needs to be at least 100 metres for it to be built. She wants to construct her flower dome close to the river so that she can use the river's water to irrigate her flowers. So the considerations here: you want to be close to the river, but you want to be set back the minimum requirement of 100 metres from the river. This requires an optimisation of the distance between any possible location and the river, and we're just going to remind you that optimisations can be found by finding minimum or maximum parameters. And in this case, we're referring to distance. The other thing that you must consider is use differentiation to find minimum and maximum parameters. So we've covered a lot of that aspect in class. Now what we're talking about here is we could look at this a couple of ways. We could say that, okay, we've got a distance running between the river and this location, and this has to be at least 100 metres, okay? So it has to be greater than 100 metres. But we could also have the shortest distance from the river and there, and that has to be greater than 100 metres as well, okay? So we can't have a property, let's say here, and let's say that this property is 50 metres from the river here, this might be 30 metres here, and it might be, turns out that it's something like 110 metres there, okay? Well, this distance, yes, that's fine, but that doesn't work and that doesn't work, therefore the location won't work. So we really need to be focused on the minimum distance from the river. Now you may want to consider in this aspect, what is your distance equation? So what is your distance equation between 2 points? And that's going to be relative to the location that you choose and the location to the Moobi River. All right. Pressing on. Context C. Jasmine hires a consultant from Kei-Hun Surveyors to assist her in locating a suitable site for her flower dome. On inspection of the site, Kei-Hun Surveyors find that half of the land parcel, or the property, is comprised of rock and clay. They provide Jasmine with the below profile of the property. Now, the property that's shaded in brown, that's where the ground is made of rock and clay. And the property that is green, that's where the property is soil. Now, because her flowers aren't growing in the ground, it really doesn't matter if she locates her flower dome in the rock and clay or the soil. She just has to have a location that's close enough to the river, but at least set back by the river. But there's this other parameter that comes into play. Kei-Hun Surveyors advised Jasmine that the excavation costs of constructing a channel through rock and clay are n times that of excavating a channel through soil. So you're going to be told that it's maybe 5 times more expensive to excavate through rock and clay, and excavate means constructing the channel, digging it out, okay? It could be 10 times, it could be 20 times, it could be 15 times. But what we want to be able to say is, okay, if for example, I had a position here, am I better off having a channel going straight through the rock and clay, or do I have a channel that might cut a little bit through the rock and clay and then through the soil, remembering that it's more cost effective to channel or to excavate through the soil. So your considerations here are going to be locations where the flower dome can be established that are close to the river, but within the constraints of the planning requirements. Cost effectiveness. Now by cost effectiveness, we mean an optimisation of any respective irrigation channel, okay? And then once we know what channel will give us the best cost, then you want to be able to articulate the direction, length, an expression or a function of that channel. So those are things that you need to consider for part 1. Okay, now it's going to be broken up into 20 questions, okay, or roughly 20 questions. So there's going to be a number of items that you're going to have to find within that context. Okay, part 2 is called Hui's Hot Horticulture. So the front cover items on this part is 120 minutes to complete the task. Answers must be given to 1 decimal place unless stated otherwise. Answers relating to time must be given in the form hours, minutes, AM or PM. For example, 1:35 PM. Now I'd be saying that you're going to the closest minute. Again, CAS and scientific calculators will be permitted, okay, and yes, you are permitted a bound reference. So the context A of this part reads, Hui is employed as a caretaker of Jasmine's flower dome. As a fellow budding horticulturalist, he is aware that flowers are very sensitive to heat. From his studies, he knows that flowers propagated in Jasmine's flower dome can only survive temperatures between 20 degrees Celsius and 30 degrees Celsius and flourish in temperatures between 28 and 32. On a midsummer's day, Hui investigates the temperatures inside the flower dome. He graphs the temperature profile between 12 p.m., 12 noon, and 6 p.m. His graph is given, it will be provided to you in the task, with the x-axis given as time and t as t hours after 12 p.m. noon. You want to pay attention to that because you need to make sure if it's 1, that would mean 1 p.m. If it comes out as t equaling 5, that's 5 p.m. Okay, so you just, if it was t 14, that would be 2 a.m. the next day. So you want to consider what time hours means. And the y-axis is given as temperature, T degrees Celsius. So for this context, you need to consider finding the function of a given curve with specified domains. So you're going to be given a curve and you're going to be asked to be able to find the expression of that curve. Just, I want to highlight here, specified domains. You want to be able to say what your min and maximum x values are going to be. Changes in temperature over time, that might involve you having to find derivatives, and the temperature thresholds to ensure flower propagation. So when it goes above 32 or it might drop below 20, then the flowers aren't going to survive. So you've got to make sure that those thresholds are upheld. Context B is to ensure the temperatures in the flower dome do not exceed 32 degrees Celsius. Hui recommends the installation of a cooling system. The recommended cooling system would automatically cool the flower dome from 32 to 28 degrees Celsius. Hui models the effect of the cooling system on the flower dome's temperature according to Newton's law of cooling. So you might want to go home and do some investigation on Newton's law of cooling. There is going to be a reheating factor in the flower dome. So obviously if we have an air conditioner operating in the flower dome that's cooling the air, okay, bringing it back down to 28 degrees, after it switches off, that air is going to reheat and it's going to rise again. And then it might rise to 32, and then we're going to have to be applying the air conditioning again to cool it back down to 28. So what we call this is a cycle of heating and cooling in the flower dome, and that's something you need to consider. You'll need to consider again changes in temperature over time, and importantly you want to consider differentiability. So what we mean by differentiability is the smoothing between two curves. So two curves can meet, okay, but they may not meet smoothly. When they meet at a certain point, and if it's a smooth transition from one curve to the other, it means that the gradient of their tangents at that point are equal, and that gives that smoothness to the curve. Okay, so you want to be able to consider that. That's it for the briefing. So you'll be provided with this sheet for you to be able to annotate, and you'll be able to ask questions of your teacher to help you get prepared. But from here, all the best and good studying, and all the best for the task. Thank you.